Hello everybody and welcome back. So in this next lesson we're going to be diving into the who.geometry class and assessing exactly how we can use this to our advantage. Now obviously we're going to want to use Python to alter geometry in Houdini because most of what we're doing in Houdini is trying to get some sort of geometry, so that we can render it. And although Wrangles can do this as well with Vex, you will find that it's very, very powerful to do it in Python as well. There are certain things that we can do in Python that we cannot do in Vex, but then also the other way around. There are certain benefits to using Vex, a few things that it can do that Python can't, or it is a bit faster if we're doing very basic things. So what we're going to do is explore exactly what we can do with it in geometry level. So I'm going to just drop down some sort of geometry. Let's just put down a grid. It really doesn't matter. All we're trying to do is assess what we can do with the actual module. Okay. So I'm going to be talking you through the who.geometry module, well, class really, but I'm also going to be talking about a few others today. And the reason for this is because the geometry class, it kind of doesn't really encompass all of everything we can do with geometry. It very much is subdivided into many types. So I'm just going to go to the geometry class over here and I'll show you what I mean. So it's sort of like with the nodes where I was saying it's a child of the sort of network movable object, and then there are subtypes of nodes which are SOP and DOP and all the other types of nodes that you can get. Well, it's a very similar thing here. The geometry class kind of encompasses all the functions that we can do to just general geometry, okay? And in a way, it sort of has all of our functions that would run at detail level. So very similar to when we have a wrangle and we run over points, vertices, primitives, or we can run over detail as in the whole piece of geometry. Well, that's sort of what we can do with the geometry class itself, okay, in a Python SOP. But if we want to dive deeper and start working on points or vertices or primitives themselves, we often have to dive to the actual point class, or the who.prim class, as well as other subclasses like VDBs and volumes, and of course attributes. So attributes have their own class. We can alter attributes from the geometry class with certain functions, and indeed from points and prims as well. We'll have certain functions that can alter the attributes. But there is also a way of just grabbing a reference to the attribute object and then running functions on that to change it or delete it or do something. So there's a lot that we can do with that. There's also groups as well, have their own sort of class with their own sub-functions. Again, that's the same. We have functions within this class that allow us to sort of almost peek into other classes and make alterations. But when we really need to do complex things, then you want to actually grab a reference and follow it on to that class and use the functions within it. Okay. Now, because there's so many different types that we're going to be talking about today, I want to just focus on the geometry class and the point class. There will be some things where point is not relevant, and then I will talk about prim or vertex. But since a lot of these things go across all of the sort of levels, so vertex, point, prim, and then geometry, well, geometry seems to be a bit separate from the others. So that's why I'm going to talk about everything we can do to the global geometry class and then one example of the subtypes. Some things will only work on prims or only work on vertices, and I will cover those. But whenever I'm talking about point, you know that you can also go and look at the prim class and the vertex class, and you'll probably find a very similar function and it'll work in a very similar way. Okay, so yeah, that's how I'm going to sort of structure this. All right, so let's talk first about being able to kind of move from type to type, or grab these references and therefore be able to run the methods within each class. Okay, now we've done that in here already with the, in fact I'll just move this aside here. Inside the Python SOP, we sort of already discussed this way of referencing the geometry. Now this is a method within the node, the who.node class, and the method is geometry, and that grabs a reference to the geometry, the who.geometry class. Okay. Now there are ways of doing that within the who.geometry class that we can grab subtypes. Okay, so for example, points. So let's have a look at this. So we'll just scroll down. I'm not sure where it is in this list. Here we are. Okay, so it's under these separate larger categories. So under points, you'll find points, but there is also one for primitives and one for vertices. Yeah, there we are. Okay, so under points here, you'll see we have points, which is going to return a tuple of who.point. And then we also have iter points, which I'll talk about now and why we would use that. But we also have this here, point, without the s at the end, and then we just give an index. So that returns just one who.point instead of a tuple of who.point. So those two are very important. So for example, if we want to grab all of our points, and we often do, we want to loop through. So we say, okay, we've got 100 points here, and on each point we want to do something. Okay, so then we would say for p in geo. Now I'm saying geo because here we have, that's our variable that we've stored our reference to our geometry. So geo dot points, okay, with no arguments, and that allows us to do something. So if I print p, okay, so you'll see now it prints literally a who.point reference to each geometry. Okay, or if we had to print just geo dot points, you'll see that it is indeed a tuple of, so it's very hard to read this, but you can see the round brackets. It's actually a tuple of all of these sort of instances of a class, the who.point class, one for each point in our geometry. Okay, so that's how we can reference all our points, but we can also say geo.point and then give it, so we just want to grab a reference to point 5. And then when we do that, it'll just reference point 5. Okay. Now we also have something called iter points. Okay. Now this creates a generator. Now what a generator is, it's essentially a list, almost like we've been working with lists, arrays. But in this case, it doesn't actually go through and create the full list. It's almost like, you can think of it as like a theoretical list. Okay, so it's like a shopping list, versus an actual cart full of shopping. You haven't gone through the shopping center and grabbed all the items and filled them and put them in the cart and then go, here's my list of items. It's just a list, this kind of just pseudo sort of like reference to the things, but you haven't actually done the work of gathering it yet. And now if I point to that list and say, well, go get item 5 on the list, it only takes you, a few seconds to go and find milk. But, even though the list is large, maybe there's 100 items on the list, you've only had to do the work once. Now, yes, if I go through that list one at a time and tell you, go fetch this, go fetch that, go fetch that, then it is essentially more work, because instead of you just going through and getting everything, I'm now having to tell you and have to come back to me every time. So if you want to loop through every single item in that list, then a normal list is better. But if you want to grab just one item from it, then a generator is better, because it's a theoretical list that it only does the work when you call a particular item in the list. Okay, it explains that here. It's got a little bit of an example. So it'll say that this is preferred. So if you're going to grab a single reference to a single point, then iter points is better. But if you're going to loop, which is like I said, if you're going to do every single item, then rather loop over an actual list that you've already gathered in one go, rather than looping over a generator. Okay, so you don't want to do that. But if you're going to grab a single point, I know we have this function over here to grab a single point, but there are other reasons why we would maybe want a whole list of points, store them in one thing, and then go and grab maybe a bunch of random items from that list or something like that. Okay, so we can do that here. We just say geo.iter points, and then obviously if I just let it run that, it's going to grab the entire reference to all of that. But you know, these are theoretical links, so these are actually not, it hasn't actually gone and grabbed and assessed each point. It will only do so when I call for it. So we can now go do like 5 like this, and it'll actually now return 5 from this list, but it only grabbed that one. It only went and grabbed the milk and didn't go and fetch everything for us to only just take milk out of the cart. Okay. And again, I'm going to just stress that I'm showing this for points. You'll find a very similar thing for primitives and for vertices. So you can grab prims, you can grab iter prims, and prim with an index. Okay. There should be a similar for vertices as well. Oh no, okay. So yes, with vertices, I'll actually show you how to grab vertices. They do not have an equivalent to grab them that way, and that's because you need to actually grab them from points or from primitives, because vertices essentially just attach primitives to points. Points have a location. Primitives are just essentially the canvas that goes across these kind of points in space, but they are attached by vertices. And so the vertex cannot exist without both a primitive and a point. And so it makes sense that you can't actually go and loop through and just grab all your vertices, because you know they can't just exist on their own. Okay. So if you're wondering why that doesn't exist here, I'll get there, but we're going to dive a bit deeper. Okay. Now, that's how we can grab them from the who.geometry class. But there are also ways to grab our points if we reference the actual who.point. Okay, so let's go down to our points again. So I'm going to open up this who.point class as well, because we're going to be working with this as our primary example. So there's the main one, and then our subclass. Okay. Now in here we also have ways of moving to different types. So we can move, if we've got a reference to our geometry, we can grab points, but we can do it the other way around. If we have a reference to a single point, like let's say here, let's store our 5th point as PT. Okay. So sure, we can print PT, and that works. Over there, it prints it. Okay. By the way, I'm middle clicking on this node to force it to cook, or you can enable and disable. Again, these Python SOPs are not ideal for something like printing or whatever, where you actually want to be able to have a button that says, okay, execute this now, but this always cooks whenever something has changed. So just showing you, because it's a good, easy way to work with geometry, but really later on, you want to design your scripts in this so that it doesn't do things that want you to actually have user input, like clicking buttons. Okay. So, we can just print our point here, but we can actually, from the point, we can grab a reference to the geometry. Okay. And therefore, from that geometry, we could grab points again or something like that, and you know, and so on. So you can move up and down between these different classes, right? So we've got geometry. We can also grab, if you see in the list here, there's a prims function. this is going to return a tuple of primitives that reference this point. Okay, so let's say pt.prims, right? That is grabbing, I'll give it a little bit of space and then force it again. Okay, you'll see here it gives us a tuple, and it has only two primitives. This is probably because we've grabbed 0.5 must be an edge point. So let me go and just double check here in my scene view, but you'll probably find that 5, yes, you see over here, 5 only has two primitives attached to it. There's the point, and it has this prim and this prim, okay, which are labeled 4 and 5, right? Now let's go back here and do this again. And there you'll see it grabs prim 4 and prim 5. Okay, so that's because it's attached like that, right? And then we can also do vertices. Okay, let me just bring up my help, and you'll see here we can grab a list of vertices. So now here is how we grab our vertex reference. It has to be through points, or we can do it through prims, right? But not from geometry level itself. Okay, so here we go, vertices. And you'll see there, so it grabs vertex 1, which is prim 4. You see every vertex has a reference to a primitive. Okay, I always like to describe this to people. You can think of points as pegs when you're setting up a tent. Okay, the points are pegs in the ground. They have an actual location, and they sort of anchor things to a certain location in space, right? So these are pegs. And then you've got your canvas, okay? The actual tent is the primitive, okay? The polygon. The vertices are the little kind of hooks, the kind of clamp things that attach the primitive, so the canvas, to the peg in the ground. So you can put down 4 pegs, and then you've got this canvas, but then you've got that little sort of bull clip thing that you just open up and clip into the point. That is what a vertex is, okay? It's useless without either of the two. If you've just got the tent and then these clips, but no pegs in the ground, then it'll just blow away, right? It doesn't exist in space, really. It is anchored to the ground, anchored to a specific location by the location of the points. And then without a vertex to attach a polygon to those points, it still doesn't matter. You've got some 4 pegs in the ground, but you don't have a tent because it can't be attached to the actual points, the pegs in the ground, right? So I found a lot of people use the word point and vertex interchangeably, and it really is not. And the sooner you kind of learn that and understand how that works in Houdini, the easier it is to understand, because I've had a lot of students very confused about the difference between points and vertices. Okay, here are points. You see, points have point position. They have a number and a position, and then your primitives do not have position. Okay, why do they not have position? Because they only exist in relation to the position of the points that form that primitive. But how do we know which points form that primitive? Well, actually, a primitive is formed by vertices, and the vertices are attached to the points. So here, our vertices, our list, so it has a point number attribute. It tells you which point that vertex is attached to. In other words, which peg in the ground that this clip is attached to. And then also which primitive, which part, like which canvas, because every primitive here is a different piece of canvas. So it's saying I'm attached to number canvas 0, so all 4 of these are attached to 0, okay, which is this one over here. So there's 4 vertices. In fact, I think we can display them here, right? So there's 4 vertices here, and they each are clips that are attached to these points. So 4 of them attached to the canvas, and they say, one of them says, well, I'm attached to this canvas and point 0. Okay, well, and point 0, and I am the second. So this 0, 1, 0, 2, 0, 3, this is the vertex number. So each clip has a number. But this clip over here Okay, even though this is clip number 2, because it's 0, 1, 2, this one is number 2, but it's attached to primitive 0 and point 11. Okay, so I hope that clarifies, and obviously if you already understand that, sorry for the digression, but really it becomes hard to work with geometry if you don't understand this, and the amount of people I've come across that don't fully understand it, it's worth going over. Okay, so now that we've cleared that up, and we know that that's the way that we can grab our vertices, is through our points. Okay, and we can also do it through primitives. You'll find that if we do go to our who.prim class, in this list you'll be able to grab your list of points and vertices, as well as you can do a single vertex with index, and maybe even, I haven't checked yet, but maybe even iter vertices. Oh, vertices is a generator anyway, so there is no iter version of it. It just is the vertices. It just doesn't. It forms a generator and not a list. It's actually strange that they have that. That it's that way and combined into one. So don't be confused by the name. Just because prims and points were both tuples, and then there's an iter version. Well, the vertices one is a generator, which is a little bit odd, but anyway. Oh, but hang on. In points level, vertices returns a tuple, not a generator. So again, that's very odd. But if you read, that's why I say you should always have this help file open. Think about this. I mean, there's no way that I would remember that every single time. I mean, I can't remember the last time I actually had to reference vertices in Python. Okay, so I know it's possible, and when I need to write a script to do it, I know I can do it. But the intricacies of knowing that at point level, if you run the vertices, it returns a tuple, but here in prim land, it returns a generator. That's something you would never remember. So keep the help file open all the time. Use it. Reference it. It is not a sort of only when you're learning. It's literally it's one of the tools that you need to use in order to code. Okay. Right. So that rant over. Right, so that's how we can grab vertices, and then obviously from prim level we can grab vertices and points. From vertices we can grab points and prims, so everything can move up and down. Oh, and from vertices you can grab the geometry. From prims you should be able to grab geometry. So in all these levels you can move to the others. Okay. Sometimes what it returns is a list, because if we're progressing downwards from primitive to points, it'll be a list. Because so prim, there's one prim, but it has a multiple list of points. But when we're on a single point, then it has a list of prims, because that one point would have multiple prims attached to it. Then if we go to vertices, you'll see there is no prims, as in with a plural, because every vertex can only be attached to one point and one prim. Okay, so yes, there are differences, but we are able to move backwards and forwards between these levels. Okay, so now let's talk about attributes. Right, so I'm going to go back to my geometry class here for a moment. And if I scroll all the way to the top, there is an attributes section, which allows us, it gives us a few methods over here that can work with attributes. And then there is also our who.attribute subclass. All right, so let's talk about getting attributes first, because a lot of the time what we're going to want to do is actually access some sort of data. So I'm going to just drop down a color node over here and put just a, let's do random. So every point has a different random color, okay? Just so that there's some attribute to be able to grab. So now, I'll get rid of my print over here. So to be able to get data from it, right? We need, don't be confused by this find, right? Because this is something that catches people up a few times. They see this word find and they think that that's getting the data. This is just checking whether the attribute actually exists. Now sometimes we're going to need to do this, so these are very good functions to know. Find point attrib, find prim attrib, okay? So that returns the actual who.attrib function. So we can do it that way. We can find it first, and then when we have it on that attrib, we can call the value. We should be able to default. Oh, there's default value. Well, anyway, this is not the preferred way to do it. So you can grab a whole bunch of data from that attribute. For example, the name of the attribute, the type, the default value, the size, all of that type of stuff from it. But like I say, this is not the right way to go about grabbing the actual data from an attribute. What we want to do is the function is called attrib value. Okay, so if we scroll down, let's find it. Where is it? Interesting. Let me try and find it in here. Attrib value. There we go. Man, sometimes you just can't see it. Okay, so here we go. Attrib value. Now it's important to note that this is only going to grab global, in other words, detail attributes. Okay, so this attrib value function has an equivalent on all of these levels that we were talking about before. And you need to be at that level to call this function. So you cannot go attrib value and then one of the arguments is asking you, okay, which level? And so it's not one global function. Instead, it's one function for every level. So if we're on global level, so in here, for example, we said geo dot. Now geo is a who.geometry class. So when I run geo.attrib value, the value I need to feed it here is the name of a detail attribute, which at the moment I don't have any, but I could go and create one. So let's just create something over here and we'll go and put it on a detail level and just call it, we'll call it foo and we'll give it a value of 3. Okay, so here now we have that in here. So if we go into this and we say, tell me the value of foo, then it'll print 3. Okay, so there we are. But there's no way to step down through this. It doesn't accept an argument like that. So if we want to grab the color, for example, for all of these points, then we need to grab our points. So that is why we would need to use something like geo.points, right? So if we wanted to do it obviously to a single point, we could just use our pt over here. Actually, let's just do it that way. So we're just going to print pt dot. Now here we're running on a who.point class, and so you'll find that there is also here attrib value, nice and convenient at the top this time, to return exactly. We give it a name or an attribute. Okay, so just note that you can give it the name of the attribute, but you can also give it an actual attribute, as in a reference to a who.attrib class. So remember here when I said you could do the find attrib and then it'll return a reference to the class. There is no sub method over here which lets you grab the value, but you can feed this actual reference into the function, the argument over here, and it will return the value for it. Okay, it's a little bit odd and convoluted, but normally you don't need to do it that way, or you're just going to give it the name, like most of the time. Okay, so we'll say point attrib value, and then say cd to check color. Okay, and then over here you'll see it has printed the color of my one random point. Now if I move to a different number, it'll print a different value, because obviously these all have different random color values. Okay, so that's how we get data from them. And again, there will be the same equivalent for prim and vertex level. All right. Now, how do we set an attribute? Okay, so let's go have a look in our geometry class first. So we'll always start global, and I'll get rid of this. Now, what we're looking for here is a function called set. Well, we want to look for the word set, right? I mean, you know, we start getting used to what some of these words mean, and so when it says set or get or, you know, find or whatever, we kind of know what that means. So we look for the word set, but we find here that there's a set global attrib value. Now, I just want to point this out again. Sometimes the naming is a little bit odd. Here, when we grab the attrib value, okay, wherever it is, somewhere in this bizarre list, attrib value doesn't have the word global in it. It just, there is an equivalent on every level, but for some reason they decided to add the word global to the global one, okay? Because on point level, it's just called set attrib value, right? There we go, set attrib value, and I think it's the same in primitive as well. Let's just search for it. Set attrib value. So I don't know why they decided suddenly that they could all be set attrib value, but then on the global level they decided they needed to specifically qualify it with the word global over there, but whatever, you know. So again, this is one of the reasons to keep this help file open, because nobody can keep up with all these weird intricacies. So for some reason over here it's set attrib value, so we'll go geo dot set global attrib value, and then we give it the name or the actual attribute reference. So in this case we'll just give it foo, because we know we've created foo, and then we give it a new value. So we'll say, okay, well, foo is now going to be equal to 5. Okay. Oh, and it's not going to like that because I've given it an integer, but foo is initialized as a float. So the type is important, right? So see here, it has overwritten it with 5, but if I go and give it just an integer, then it doesn't like it, because just by giving it an integer, Python can convert from different types very easily. But it's having to work with Houdini here, and Houdini doesn't like you to just randomly feed it incorrect values for an attribute. It's not going to suddenly convert that attribute to an integer. So you need to give it 5.0 or give it 5, but encased in a float cast or something like that, and then it'll work and give you that value. Okay, so set global attrib value, or at point level we could just say pt dot well, maybe we'll just go, so for p in geo dot points we'll say p dot set attrib value cd, and we'll set it to be equal to one specific value. So even though we've fed it a this is here is going to want a who dot color, so 100. So we'll feed it that. Oh no, that doesn't even work as well. Interesting. Let's have a look why. Let's learn from this. Okay, so this as far as I'm concerned should have worked. So let's read the error and actually see what's going on. Okay, so here type error in method argument 3 of type vector. So it's saying that this is the wrong type. Okay, it is argument 3 because remember it always has self, which is invisible, and then this one is argument 2, and then this one is 3. So it's essentially saying we're giving it the wrong type. Okay, that's odd. Right, let's try and give it a tuple, because I gave it a list earlier. No, still not. And if we do a who dot vector 2, vector 3. Okay, there, that works. That's very odd. Okay, but anyway, good lesson over there to see how the error helped us learn something. You know, see here, there's something that I wasn't really sure why it was broken, but instead of having to now, I don't have to Google or just go, it's not working at all, contact side effects, or give up being an effects artist altogether and, you know, go sell coconuts on the beach. No, like, just read the error and it'll tell you why it's complaining, and then you can kind of try and figure it out. Okay, so I don't know why it specifically needs a vector 3 for that, even though we're feeding it a vector. I wonder if we typecast it. Let's try this as well. If we typecast a tuple as a well, there's no typecasting for vector. Okay, so that's an interesting one. Kind of strange. Anyway, let's move on. So yeah, that's how we set attributes. Now, again, I said on prim and vertex, it's just called set attrib value, but then on here it's global. And then sometimes we're going to need to create attributes as well, if they don't already exist. Now, with this, it kind of works the other way around. We create it on geometry level always, regardless of the class, okay? So the function we're looking for is add attrib, but you'll find that there's an add attrib and it asks the type, okay, and the name and then everything, you know. So we're filling in all the details for it, but this type is very specific because that is determining what level. So is it point, prim, vertex, or global, okay? It is a bit frustrating that sometimes some functions are just only on global level, but they allow you to specify a type, whereas other times they don't. There's one function on every level. So just, I don't know, you just have to kind of learn it, unfortunately. As far as I know, there isn't there's no add attrib version on every level. Let's check in here. No. So there's the only way to add attributes is on global level, because you're adding it to the geometry, but then you're just setting the type of that. So we would go and do that. So say geo.add attrib, and then we specify the type. Now the type, be aware, especially when you see it here in purple, it's kind of telling you that this is a specific thing. Doesn't want a string. So we come in and read, and it says it's a who.attrib type. So we specifically have to, you can middle click on these and it'll even tell you. So this is a module, okay, sub-module, like when we did the flags and things like that, which has a bunch of types in it, okay. So when we fill this in, we actually literally have to say who.attrib type dot, and then we feed it whatever. So let's create a primitive attribute for now, okay. So we can say our type is primitive. We also have to give it a name. You see, this is not a default. There's no equal sign, so we have to give it a name. So let's call it my attrib. Then we give it a default value. We have to give it a default value, right? And it also the default value determines the attribute type as well. So we've determined the type as in the prim, point, vertex level, but the default value determines the actual value type. So is it an integer, a float, a string, or whatever? So be very careful. If you go and say, even if you want the default value to be 0, but you want it to be a float, if you've said just 0, you're going to create an integer. You must say 0.0 if you want it to be initialized as a float. Okay, so let's actually show that. And then transform as normal and create local variable. Those are they have defaults, okay. And create local variable is kind of weird. It should be false by default. It's a very old school way of creating attributes, is to have a var map. Nobody uses these var maps anymore, so we'll leave it on by default to show you what that is. But okay, so when we run this, you'll see over here on primitive level, we have this attribute. But what is it? If I middle click and I see this attribute, you'll see it's an integer attribute. And only if I change the 0 to 0.0 is it now specifically a float. Okay, so be very careful of that. And also you'll see it's created an additional attribute over here on geometry level, on detail level, called a var map, which lists that my attrib. And then this is the way that we can call it with $. So $, and then all capital my attrib is a way to call this. But we do not need that anymore because we just use the vex style at my attrib. So I would probably go and set that to be equal to false. Now remember, if we are wanting to skip this argument, which has its own default, and just go to this argument, then we need to specify the keyword name. Okay. So we're just going to say here, create local variable equals false. and now it won't create that var map because it's totally old school. Okay, so that's how we add an attribute, and it always has to be done at geometry level. All right, so now let's talk about creating some geometry. We can, as I've said before, have an input here, and whatever comes in on the input will also come in on the out. And we can add geometry to this. So we can create geometry while we already have geometry, and it'll simply just add it into it. But another way to do things is to just have it have nothing, so have no input. All right. Now, obviously, these functions are then going to fail because they are looking for something. But this will not, and this is important to know that when we run our node.geometry function, this method, it is returning a reference to our who.geometry class. It doesn't matter that there are no points in it, no primitives, no vertices. It still is a reference to the geometry. And that's important because we need to be able to reference that geometry to add our own geometry into it. Okay, so it's essentially just an empty geometry container, right? When we middle click here and it tells us that we have 0.0 prim 0 vertices here, this is our bounding box, these are the attributes we have. All of that is information about the geometry. Just because it happens to have a bunch of zeros does not mean that this is not still a geometry reference. Okay, now let's create some geometry. So take away this add. And be careful. Add, you can only add things like attributes. When we talk about geometry and actually creating it, the word is create, not add. Okay, so if you're looking for the add point, it does not exist. It's create. Okay, so we can create point, and then there's also a create points that allows us to create multiple points in one go. Now, create point always creates a point at 0, 0. Okay. And then it returns the point that you've just created. So if you want to create one point at a time, you actually have to create the point and store that reference and then go and set that point's position. If we do it through this create points function, then it allows us to feed a list of point positions. It will then, for each one, we'll go and create those points, and returns a tuple of all the points that it has been created, that it has created, right? Now the point positions we need to feed it must be who.vector3s, right? So you've got to feed it a whole list of vectors because it needs x, y, z for every single point that you're feeding it. Okay. So let's just create a single point. So we just say geo.create point, and it'll create a point. Okay. Now, obviously, if I want to do anything to this, I need to store a variable. So I say pt equals, and now I can say pt dot, and now we can do other things to it. We could, we could add an attribute, but obviously we wouldn't do that on point level. We could check its attributes or something, or we could set its position. I just want to point out that although we can set attribute values, there is a shortcut for setting position for points, right? Oh, sorry, not on this level, on point level. You'll see that there's actually a set position, okay, which is just an easier and quicker way of actually moving points around, because they know that you're going to want to do that really often, so you can do this. You can still do it with set attribute value, but basically it's just an easier, quicker way. Okay, so we can set position and set it to maybe 0, 1, 0. Okay, and obviously that errored because I didn't encase it in brackets, because remember what it wants is a single value, which is a tuple, right? And now you'll see that that is at 0, 1, 0. Okay, so we've altered our y position. Right, so the set position, that's just another function that you'll probably use. But yeah, see, so we've been able to create a point, or we could create multiple points through a list as well. So maybe positions equals, and then we can go and create a list. So we can say maybe 0, 1, 0, and then 1, 0, 1, and 4, 7, 2, whatever. Okay, so we create this list, and now we say geo.create points with the S on the end, and then we feed it a list of positions, and then it goes and creates those points at those positions. Okay, and also if we return this, so points, and then I can print points or something like that, and you'll see that it returns a tuple of that. Okay, so we can then loop over those and do whatever we want. So that's how we create points. And you can do the same kind of thing with primitives. So at geometry level here, create point, create points, and also create polygon, create tetrahedron. We can create a NURBS curve or Bezier curve. We can create volumes. So there's a whole bunch of create functions. Okay, there also creating groups is under the word create, but that's obviously a little bit different. You need geometry in order to create the group. Right. Okay, so let's clear that and move on. So we can create geometry. Actually, wait, let's bring that back because we've got some geometry here. Why don't we also then delete some geometry, right? So clearing geometry, getting rid of it, in this is now not called destroy like when it comes to nodes. It is actually called delete. Okay, so it's all on geometry level. Right, so creating and deleting, it's very similar to also adding attributes. It's all done at geometry level. So delete points and delete prims. Okay, and then we give it a list of points and primitives. And then when we delete prims, you can tell it to keep the points or not. So does it delete the points that were attached to that primitive, and or does it just get rid of the primitive, as in that canvas, but leave the actual pegs in the ground? Okay. Right, so let's delete one of these. Let's delete point 2 because it's all the way over here. Right, so what we do is we reference our geometry, so geo dot and then delete points. Okay, but what it wants is a sequence of points, right? So a sequence of points there, which is a list. Now it needs to be an actual list of points, so that first of all we need to reference the point itself. So it would be geo dot point, and then we can give it the vertex number, the point number, so it's just 2. Okay, so geo dot point, and that'll return that, but this will still not work, okay, because it's saying it's the wrong type. It wants a sequence, not just a single one. So we need to give this as a sequence. Okay, so wrapped in a tuple, but it still will not work because it actually needs, so this single item encased in brackets doesn't really register as a tuple unless we go and put a comma. Okay, so I know it's a little bit odd, but we actually have to feed it that one item and then comma, and then it will read it as sort of, it's a list, but it's just a list of one item. Okay, this is a little bit odd, but you normally don't need to actually, you very rarely are going to delete a single point like this. Okay, you're normally going to be looping, and when you loop, you're going to have an actual list. You know, you'll kind of gather a list, maybe check a certain attribute value, and then build a list based around all the attributes, the points that you want to delete based on that attribute, and then you just feed that list in here. So then it would just be, you just feed in the one argument would be the variable that you've stored your list in. So doing it this way is a little bit kind of roundabout. In fact, let's check if there is an actual delete equivalent. No, there is not. See, this destroy has not been implemented yet, but they are going to actually hopefully soon bring this in, so then you'll be able to reference that single point and just destroy it instead of having to do everything at geometry level. Okay, but for now we have to do it this way, but typically you're going to have a list anyway already, so you'll have this whole list that you want to go and delete, and you'll just feed it in like here with their prim example. Okay, you build a list and then delete the list. Okay, so same with prims as well. Okay, so that's creating and deleting. Now let's just talk about groups for a second. Okay, so actually we'll keep this up because we've got these two over here. So you can find groups, so check if a group already exists. Okay, which obviously to do that we'd need to, let's go back to our original geometry over here, and I'm going to go in and just select some points and put them into this group. Okay, so okay, well I've actually selected primitives. Let me go to points here. Okay, so that's fine. There we go. We've got a list of points in a group. Okay, and now if I go, sorry, let me just deselect, and I'm going to just drop down another Python SOP over here, because we obviously can't check for a pre-existing group in a node that has nothing plugged in and is generating all the geometry on its own. So that's why I'm just going back to our original here. So we can search for a group to essentially check whether it exists, but also grab a reference to it. All right, and that is called find point group. Okay, over here. In fact, if we just go down to the groups section, where are we? Yeah, there we go. So find point group. Also, you can get a list of point groups, and then you could iterate through them if you wanted to. And then here we're going to create group as well just now. So let's first find it, because that's going to give a reference to the point group. And on this, we can then have a whole bunch of methods that we can do to it. So we can grab a reference to the points that are in it. We can clear and remove it, or add points into that group. So we first need to actually reference that group. And you'll see here that on geometry level, there is no way to add to the group. Okay. Even when we create a group, there is no way to add to it. So with groups, you have to reference the who.point group or prim group or vertex group class. And it will then have the ability to add to it, remove from it, clear it, or even delete it, which is kind of strange. You can create a group on geometry level, but you can't delete a group on geometry level. You have to reference the group and then destroy it by referencing it, which is kind of strange. Right, so let's do that. Let's go and find our group. So our group was just, I was terrible and didn't give it a name. Don't do that, guys. Please give it something, whatever you want to call it. And now we'll go in here, say geo.find point group, but there is also obviously find prim group and so on. So it's a different function for each type that we're referencing. So find point group, and it just wants the name of the group. So we feed it whatever. Okay. So that'll return a reference to our group. So we need to actually store it here. So I'll just call it group equals. And if I print group, you'll see it's going to reference a point group. And then we can say group.points. In fact, print them. So print the points, and it's going to print a list of the points just in that group. Or what we could do, well, let's take a look at this list for a second. We can grab the name of that group, or we could see if it check whether it contains a certain point. So we can say group.contains, and then we'd feed it. Now I'm assuming it wants an actual, it doesn't actually specify, so let's try it with a point number. Let's just say is 0.9 in the group. Okay, no, it doesn't like that. So we would have to do a geo.point9. Okay, and then it's going to say false. So no, 0.9, which is in this corner over here, is not included in our group because our group was way in the middle there. Right, so that's a way to check things. And then you can also add to it. So well, we say, well, if not, so if group 9 is not, well, 0.9 is not in the group, then group dot add. Yeah, it's just add. So group dot add, and then you give it a point or list or point group. Okay. So again, I think we need to actually reference the point. I don't think we can do just point number, but let's try. Because sometimes it has it built into the function where it allows you to just give it a number and it assumes, okay, let's, if they give me a number, then I'm just going to assume that they mean that point number and it grabs a reference to it. So we had 20 points in our group. We now have 21, including 0.9. Okay. All right, so there's a lot that we can do with groups, and they, you can read through the help file, but basically there's a lot. There's, add, contain, or if we can clear it as well, we can say group dot clear, and then it literally empties the group, or we can say group dot destroy, and then it no longer exists. Okay, so lots of cool functions, but they all are contained within the actual who.point class, except for just creating a group that didn't exist before, or finding a group. Okay, or you can find them just by listing a whole list of your point groups or prim groups. Now to create a group, you just would go geo.create point group, and there's also a primitive one, and then we would just give it the name and then say whether it's an ordered group or not, but that's default. So we would just create something like that, and now it just creates a group. Okay, but something is empty, we would literally have to grab a reference, my group equals, and then you'd go and add points to it. So you'd go my group dot add, and now add geo.point 3 to it, and now we'd have a single point in that group. Okay. All right, then let's move on to intrinsics. Right, we're almost there with this. I know there's a lot to cover, but we're getting there. So just want to point out that prim intrinsics are an important part of Houdini, and it's actually often overlooked, basically because they're hidden. So a lot of people don't even know about them, and particularly when it comes to volumes, your prim intrinsics are really important. But your intrinsics are basically attributes that are created automatically, okay, intrinsically. In other words, they have to exist because other things do exist, or based on the conditions or the state of the geometry, it needs certain things, right? So it has bounds, for example. Your geometry will have bounds, even if it's got nothing in it. If it's empty geometry, your bounds will still be 0, 0, 0. Okay. It needs to know the type name, for example, because polygons are handled differently depending on whether they're polys or polylines or primitives or whatever, so there's a whole list of things that it needs to do depending on the type. So there's no way you could delete this type and just not have it, or oh whoops, I forgot to create it, so then your whole geometry breaks. The Houdini would be really counterintuitive if that happened. It would be very difficult because you'd have to go and initialize all of these attributes. So these are created automatically for you. And particularly with volumes, it's really useful, because if you ever have a volume with varying density, but you want to be able to maybe ramp that density, you need to fit your density between a 0 and 1. Now your volumes, VDBs don't have it, but normal Houdini volumes do have a min and a max density value. So you can reference your min, reference your max, use that to fit your density, and then put it through a ramp. Okay. And with VDBs, you can do it just by converting to a normal Houdini volume, check the min and max, and then fit the VDB. All right, so very important to be able to reference those, and there is on geometry level, on geometry level there is, I think, yes, intrinsics here. So you can grab an intrinsic value, but also because there are intrinsics on detail level as well. Okay, so a couple of things. We can show all of them. Some of them are useful, some of them are not useful, but we can see a whole list of things, like, for example, like memory usage and things like that. But there's all this data. Very rarely have I ever needed a detail one, but if you ever do need it, it is available. Okay, so you can grab the intrinsic value. Now this on geometry level is only going to be talking about the ones on detail level. Okay, so the global ones. you have to go to prim in order to find the intrinsics for that particular here. So unfortunately, they're not grouped under things like on geometry level, but they are here: intrinsic value, intrinsic names, etc. So, and unfortunately, there's no documentation for it, but it is pretty straightforward. You want to get the value of a certain intrinsic, a prim intrinsic, then we just go, we reference a primitive. So we would just say geo dot prim, and then just take prim 0, and that'll be our, so p equals, and then we would just say p dot intrinsic value, and then give it, let's have a look at what options we had. Maybe our type name. Okay, so it's called type name. So let's go and check what our type name is for this. So let's print it, and it says that prim 0 is a poly. Okay. Now, obviously, I mean, we could go just check it manually, but sometimes you want to reference it. Like I said, with volumes, you want to go and grab your min and max and then fit it so that you could actually build a Python node that procedurally goes and fits all of your volumes to a 0 to 1, or it could normalize your vector volumes and stuff like that. Right. So that's intrinsics, and then so finally, I just want to finish off with a few just random ones, because these are all sort of groups. Like I've written down a list of group sort of functions that are useful, things like creating geometry and whatever. But there's a few random functions that are just always going to be useful. One of them is this who.geometry.freeze. Now, I did explain this in the previous lesson, but basically, if we don't have frozen geometry, then what we're doing is we're working on live geometry. And because here we can loop, we could loop through our primitives and delete a bunch of them, which means that within that one loop, okay, we've altered our geometry. So now when we loop again, we don't have as many points as we had before, or the actual situation has changed, and that's sometimes not what we want. So we create essentially kind of a copy, a reference of this geometry frozen, so we can loop through the frozen stuff, but then apply what we want to the original geometry. That way, as we delete a bunch of primitives through Python or whatever, when we loop again, we loop through the frozen geometry, it still loops over the primitives that used to exist. Because what you may want to do is, let's say you want to remove some points, but then you want to get also an average of what the values were. Well, grabbing the frozen geometry would give you an average over the whole thing. Who.geometry or node.geometry is going to grab just what's left after that loop. Okay, so it's important to know the difference between frozen geometry and non-frozen. Okay, and okay, then let me see. Oh, a bounding box. Bounding box is something that you'll probably find useful. So there's a bounding box function and a point bounding box function. So those, and then obviously a prim as well. These are very, very useful because sometimes you need to actually see what space your geometry is taking up. Okay, and if you want to, start looping through that space and maybe scattering points, you need to know which the bounds that you need to loop over. Okay. We can also, for point level, on points, there's a few cool functions. So I showed you set position, but also there is position, which is a shortcut way of grabbing the position without having to do the whole get point attribute value. You can just do dot position. And also grabbing your point number is useful. If you have looped over those points, you want to actually grab the number because you maybe didn't feed it in manually. And then under vertex, there's one very useful one, which is linear number. Okay, so you've got your vertex number, but then you've got your linear number, right? Because the one goes essentially, like let's say you've got two lines. Okay, so let's actually do that. Draw curve. Okay, so we're going to draw two lines here. Draw a line and another line. Okay, so we would then drop down a Python SOP, and then we're going to loop through all of the, now in order to grab the vertices, we need to go to the prim level and grab vertices. Okay, So we're going to go grab our two prims. Okay. So we'll say geo.prims. Okay. For prim in geo.prims. And then I'm going to create an empty list over here. So we'll say something like vertices equals and an empty list. And then we'll just say prim.vertices. We'll grab all of the vertices. Okay. But we want to append those to this. So we would just say vertices plus equals. Okay. So we can just add to that list. Okay. And then when we print vertices, it's going to print a list of all of our vertices, which includes across both primitives, okay, because we looped over both, right? I mean, there are multiple ways of doing this, but that's one way of grabbing all our vertices, okay? So now if I actually print for v in vertices, let's print v dot, and what I want to print is the number, right? So vertices dot number. It's going to print our vertex number. Okay. Now you see this goes 0 to 16 and then starts at 0 again. Okay. Now that's sometimes what you want, because if you're wanting to do, for example, a gradient, you need to know your normal sort of your vertex number. Okay, so 0 to 16 and then 0 to 11, because you want both of these to go 0 to 1. So then you just fit it based on the number of vertices in each primitive. But sometimes you want your actual linear vertex number, which is just all the way. So instead of this 0 to 16 and 0 to 11, you want it literally to be like 0 to 28. And it's essentially, it's almost like a point number, but it's just based on vertices instead. And so if you go linear, and I think it's a capital N, linear number, it will then print 0 to 28. Okay. So as soon as it moves to the next primitive, it doesn't start at 0 again, it just continues. All right. Okay, so that's very, very useful depending on what you want to do when working with vertices. You need to often convert back and forth between your linear vertex number and your normal vertex index, your prim vertex index. Okay. All right, so I hope you guys found that very useful. There's a lot. I mean, especially with all these subcategories, there's a lot of functions. So I've tried to cover the ones that I think are the most useful, but please feel free to actually explore and see what you can do with geometry. Okay, there are loads of types, loads of cool things you can do. Like if you even go to the bounding box type itself, there's loads of cool things you can do with it. So explore all the different ones and have fun. Just literally play around for a while and see what you can do. Okay. All right. So thank you, everybody. And I'll see you in the next lesson, where we're now going to actually take everything we've learned up to this point and start putting it into practice. And we're going to build quite a cool, fun, and like complex example that really challenges what we've learned up till now. All right, so I'll see you then.